This exercise or this problem is truly wonderful and very important. It's not very hard, as you will see. It doesn't need some very profound, tricky ideas. No, no, no. It's just whether the students do know the concept of lim_inf and lim_sup. Keep in mind that if a sequence is bounded, lim_inf and lim_sup are numbers. They do exist, while the limit may not exist. In other words, the sequence may not be convergent. So the second part of the problem is really beautiful because it clears some misconceptions about these two concepts. Okay, so let xn be a sequence of real numbers. Okay, so how do we define the lim_inf and lim_sup? The way I see it is to introduce two numbers. So let's consider mn for every n to be the infimum of xm, okay, where m is greater than n. And capital M, n, is equal to sup of xm for m again greater than n. So, easy to check that for every n, we have xn between these two numbers, mn and capital M sub n. Now, what's interesting about these two numbers is that the sequence of mn is increasing and the sequence of capital Mn is decreasing. So one is increasing and one is decreasing. So you have this sequence xn squeezed between two sequences, one from from below, which is increasing, and one from above, that is what? Decreasing. So what is now the lim_inf when n goes to infinity of xn is exactly the limit of mn, and since it is increasing, it is indeed the sup of mn, of the sequence mn. And of course you can replace mn and you will have now the traditional sup of inf of, okay? And the same goes for limit sup of xn when n goes to infinity is limit of capital Mn, and since capital Mn is decreasing, this is the infimum of capital Mn here. So what does this tell? So now if we take any subsequence, let's say for example, okay, we may need just to clear the air, for example, that if the sequence, if lim_inf is equal to minus infinity, uh, and lim_sup is equal to plus infinity, then the inequalities are trivial. So we may assume, without loss of any generality, we may assume that minus infinity is less than lim_inf of xn, and less than lim_sup of xn less than plus infinity. Here, I wrote something interesting, which is that the lim_inf is less than lim_sup, and that comes from the inequality we have right here. Okay, so you have the small mn less than capital Mn, and they are both of them convergent. The lattice properties of the limit of convergent sequences will give it to you. Okay, that the lim_inf is always less than lim_sup. Okay, now that we have this, we note also very simple check. One may check very simple that if we take minus xn, then the lim_inf of minus xn when n goes to infinity is exactly minus lim sup of xn. So this is very common, for example, where you have some kind of lattice dualities. It's lattice duality between the infimum and the supremum. So for a proof, you just need to prove one, and you will get the other one for free. Okay? So in other words, by duality here of the lattice or the order, and this trick of multiplying by minus. So here we will focus mainly on prove. Let us prove that it is proved that lim inf of xn when n goes to infinity is less than lim inf of x and k when nk go to infinity for any subsequence x and k, for any subsequence x and k of xn. Okay? In other words, that lim inf of xn of the whole sequence is the smallest of all the lim inf of any of all the subsequences. Okay? So how do we prove this? Very easy. So we look at this mn. So let's call mn bar or mnk to be the one associated with the subsequence xnk. In other words, you are looking at the infimum of xn I, where ni is greater than nk. Okay? So obviously, what do we have? We have mn, okay, which is less than mnk whenever nk is greater than n. So remember that mn is the one that is associated with sequence xn. Okay? So now mn has a limit, mnk has a limit. Therefore, we have a limit of the mn is less than, when n goes to infinity, to the limit of mnk when nk goes to infinity. And for this one, what you do, use the fact that they are increasing, both of them. So you start with mnk, okay? It's less or equal than the limit, because the limit is the sup of the mnk. And this sup of mnk will be greater than all the mn, and this will imply that the sup of the mn also is less than the sup of the mnk. Okay, so it's very important to have this limit being of the increasing sequence being the supremum of that sequence. Okay, which gives us exactly what we want, meaning that lim inf of xn is less or equal than lim inf of x and k. Okay, so now that we have proven the first part of the problem, what if x and k is convergent? If x and k is convergent, then we know that the lim inf of x and k is equal to lim sup of x and k equal to limit of x and k when nk goes to infinity. Then we obtain that limit of the subsequence is going to be squeezed between lim inf of xn and lim sup of xn. Okay, so this is a little bit more precise, and of course we obtain for free that if the whole sequence is convergent, in other words, lim_inf is equal to lim_sup of the xn's, then any limit of any subsequence will be what? Will converge, and it will be also equal to the limit of the whole sequence. Okay, so we obtain the fact that subsequence of convergent sequence are also convergent, and they have the same limits. Okay, so what about the last part? As I told you, the trick is if we take al, any number between lim_inf of xn and lim_sup of xn. Okay, so is L a cluster point, or L is a limit of a subsequence of xn? Okay, so this is the question, and you need some properties on the xn. This is false, of course, but we may get this conclusion if we assume some kind of Tauberian condition. I don't want to, it's beyond the scope of this problem, but let's just show that it's not true. This one is not true. So for example, if you take example, so if we take the sequence -1 to the n, or 0, 1, 0, 1, 0, 1, this will do it. So we know that there are only two values, -1 and 1, and therefore the lim_inf of -1 to the n is -1, and lim_sup of -1 to the n is equal to 1 when n goes to infinity. But there is no way that, for example, there does not exist any subsequence which converge to 0, for example. Okay, if we take 0 in between. So the result is not true. This second part is not true.